All right, this video is to help you with your homework in section 8.4, page 531, and it's going to focus on the dividing of the rational expressions, but the whole thing is multiplying, dividing, and simplifying the rational expressions. So I'm going to help you through 3 problems, and everything that happens with division can be applied to multiplication, because one of the first things we do with this is change it into a multiplication problem by flipping over the second fraction, because that's how you divide fractions. You flip over, take the reciprocal of the second fraction, and then you multiply. So you do the inverse of the fraction, which means you get to do the inverse and multiply instead. Because we really don't know how to divide fractions, we invert and multiply the fractions. Okay, so restrictions on division are trickier, because what you have to do is you have to think about this can't be 0 because you'd be dividing into that fraction. So y cannot be 0. Okay. And then you have to think about this as well here, because if this was 0, then this whole fraction would be 0, and you'd be taking 0 and dividing it into something. So that can't be 0, and that can't be 0 as well, for obvious reasons, because you can't divide 0 into that there. Now this is the same restriction, because if y was 0 here, then it'd be 0 to the negative third power, which is 0 times 6 is 0. So y can't be 0, so that's just repeated from there. And then here x obviously can't be 0, because 0 to the negative fifth power is 0. All right, so we're going to invert and multiply. And negative exponents, we get to use the rule cross the line and change the sign. So if you have x to the negative 2 from our rules of exponents, remember this is 1 over x squared. All right, so my restrictions are right here. Okay, because none of that stuff can be 0. One of my students came up with D and D, denominator, numerator, denominator. You got to worry about that with division. So the restrictions are denominator, numerator, denominator for division only. And then for multiplication, it's just the 2 denominators. Anyway, now I'm going to flip 3x cubed over 5y squared times 5x to the negative 5 over 6y to the negative 3. Now I'm going to cross the line and change the sign. So the y is going to go to the top and the x is going to go to the bottom, and you cross over the fraction line, you change the sign. So it's 3x cubed over 5y squared times, now the 5 doesn't move because it's not attached, the 5 is to the first power, so you don't move it. And then the y to the third comes up. The 6 doesn't move because that's the first power, so it doesn't move, but then the x comes down. Okay, so this is the multiplication problem now. So then we can start hacking things away. Let me get out an appropriate hacking pen. Orange looks good. And 5 divided by 5. So you can cancel things out above and below each other or diagonally from each other, because the top of the fraction means to multiply, bottom of the fraction means to divide. So really that's 5 divided by 5. Same thing here. 3 divided into 3 is 1. 3 divided into 6 is 2. All right, now we're going to take care of the x's. There's 2 or x's, I guess. There's 3 x's here, 5 x's there. So 3 of these x's are going to cancel out with 3 of these x's. So that would leave 1 there and squared down here, because when you subtract, it'd be 5 or 3 minus 5 is negative 2, but then it'd go down to the bottom of the fraction. So down here I have this left over. And then the same thing here. This goes away, turns into 1 or whatever, and then I have y up here. So the 3 is gone because it went into there. This is gone because it went into there. And that's gone because it went over there. So the only thing left on the top of the fraction is y. And then on the bottom of the fraction, that all turned to 1s, and then 2x squared. So that would be the final answer for this one. All right, the difference on the next couple of problems is we're going to factor. We really didn't need to do any factoring here, because we understand that x to the third power means x times x times x. And x to the fifth power right here, right? X to the fifth power means x times x times x times x times x. So there's 5 x's that are multiplied together. So we got 3 x's here, 5 x's there, leaving the 2 on the bottom. So we kind of see how it's already factored. Now the next ones we have to go ahead and do some factoring so we can cancel everything out perfectly. Alrighty, the next problem here we have to factor because you can't see what exactly to cancel out. And we're not allowed to cancel out things unless they're like factors. You have to always cancel out like factors. So I'm going to go ahead and factor everything. So we can take a 3 out of these two, the common factor. This is taking out the greatest common factor, so I get 3, and I get something left over. Down here I get 2, and I get something left over. And times, I'm going to change it to times. I'm going to factor as I go here. So this is going to move to the top. And so it's going to, I'm going to take out a 4. So that is going to turn into this guy. And then this one here is going to go to the bottom because it's going to flip upside down, and I'll take a 6 out of that. So that's the greatest common factors here. There's no variables in common. I'm just numbers that I'm taking out of each one of the binomials. So now I fill in what's left over, and then notice I flipped and factored at the same time, and that's okay. I'm gonna bring this here, bring that there, change it to multiplication. So if this was a multiplication problem, then you just start off with figuring out what the factoring is and the restrictions. So fill in the blanks, and you're welcome to pause the video and fill in the blanks yourself and then see if you got it right. So it's y minus 4, and then y plus 2, and then y minus 4. Oh, whoops. I didn't do the flippy thing, did I? There, I caught myself. I confused myself. Okay, so this guy is going to go up here. So this would be 2 plus y, and then this one would be y minus 4. There we go. Now we're cooking. Now I'm going to do the restrictions. Now with restrictions, remember you have to check in all 3 places because that can't be 0, because 0 over something would be 0, and 0 divided into this first thing here would definitely be bad. So division, there's 3 things. So that means it's basically equivalent to what makes all of these 0. What makes this 0, this 0, and that 0. So how about negative 2? Negative 2 plus 2 would be 0, so y cannot be negative 2. That's my first restriction. How about 4? Y cannot be 4. And then negative 2 again. So those are the 4 restrictions. Or 2 restrictions, why did I say 4? From the 3 places. And now we can start hacking things away. Those are the same, so they go. Same thing divided by the same thing is 1. These are the same, it's just the order switch. You can switch the order of addition, no problem. And then this, you can look at this a couple of different ways. We have this left, this left, this left, and this left. So you multiply numerator times numerator, denominator times denominator, so it's 12, right, over 12, which is 1. So that's one way to look at it. So that's the answer. And then those are the restrictions. Another way that you could look at it is you could say, hey, 2 divides into 4 2 times, so there's a 2 left over there. And then 3 divides into there 3 times, so there's a 2 left there, and then 2 over 2 is 1. So it all goes to 1. Either, however you want to think about it, slice it or dice it. The answer is 1, and then those are the restrictions. All right, here's the last one. So I'm going to do the whole factor flippy thing at the same time again. So we got this kind of factoring is the old 2 sets of parentheses, put in x in each business. Okay, this doesn't really need to be factored, so 4y squared comes to the top. Change it to multiplication, then factor again. And again, like I said, you can pause the video and factor, see if you get it right and all that good stuff. Okay, y and y. 2 and 3 makes the 5, so it's 2 and 3, and then 2 negatives. And then 5 and 2, so it's y and 5 and 2, and the positive 5 and the negative 2. All right. Now again, the whole, if this was just a multiplication problem, if it was just this, I would say restrictions came from here and here, right? If it was just a multiplication problem, because they come from the two denominators. But here we have to do, because it's multiplication, denominator, numerator, denominator, and that's the three places where restrictions. Luckily, those two have the same restriction. Y cannot be 0. So y cannot be 0. And then 2 minus 2 makes 0, so y cannot be 2. So if you were to graph this, we'd create the vertical asymptotes. And then negative 5 plus 5. So we get three restrictions, 0, 2, and negative 5. Now we're going to start hacking things away. That's hackable. That stays. So I got y minus 3, that stays on the top. The y plus 5 stays on the bottom, that can't cancel out. And don't you dare try and cancel that way, because they're not like factors, so you can cancel out factors. 4 has no partner, so it stays. So this stays, so the 4 comes down here, it's multiplied across the top. And then y to the second versus y to the third, well, there's two y's multiplied together here and 3 down there. So matching those up, or subtracting, dividing like basis, subtract the exponents, however you want to think about it. So these two cancel out with 2 of them down here, so there's one y left on the bottom. So the answer is 4 times the quantity y minus 3, and then y times the quantity y squared plus 5. So typically in calculus class, what we do is we leave the bottom of the fraction, the denominator factor, and we simplify the numerator. So keeping the flavor of that, 4y minus 3 over y times the quantity y plus 5. Okay, so either answer is okay, and then those are the restrictions.